Today we're going to look at some advanced topics in SQL. Here's a quick overview of what we're going to cover today. We'll start by looking at some ways for working with dates. We'll learn about the data types for working with dates and time. We will also look at ways to extract parts of a date. Then we'll talk about creation of dates, the different ways in which you can get the current date, time, and you can add and subtract intervals to those dates and times. And we'll look at some date arithmetic, things like finding differences between dates or adding times, removing times, and such things. We will then also look at formatting dates. In a lot of cases, you will have to display dates in nice human readable formats. So we'll look at that. And we look at the opposite of that, which is date parsing. So given a string in a certain format, how do you interpret that as a date and store that within SQL? Dates are important because almost all data that you'll work with will have some form of time or date related information that you will need to process and query against. So that's why it's important to know how to work with dates. Then we will look at some advanced clauses in SQL. We will start by looking at the group by and having clause. We've seen group by already in relation to aggregation. The having clause is an extension of that used in special cases. We will look at common table expressions that allow us to take out subqueries from complex statements and express them with a specific name. We will look at the concepts of union, intersection, and difference, which allow us to combine the results of two independent queries. We will also look at the case, when, then, else statement, or just the case clause, which is used to implement conditional logic within a SQL statement. After looking at these advanced clauses, we will also look at some advanced type of SQL statements. So you can do more in SQL than just query a table or a database. You can create something called stored procedures to reuse code. Another way of reusing code is to create stored functions, which is a way of creating functions with custom logic and use them in the exact same way that you use inbuilt functions in SQL. Then we will touch on the topic of recursion, which is a query that references itself and builds on top of its own result. So that's everything we're going to look at today. Let's talk about the database and system setup that you'll need to do so that you can follow along with this lesson and try out the queries on your own computer. We'll use the Classic Models database to experiment with window functions. Classic Models Incorporated is a fictional distributor of small-scale models of cars, motorcycles, planes, ships, and trains, etc. And here are some of the products that they sell. Classic Models has offices around the world with dozens of employees. The customers of Classic Models are typically toy or gift stores. And most customers have a dedicated sales representative who is an employee of Classic Models. Customers typically place orders requesting several products in different quantities and pay for multiple orders at once via checks. So let's look at the entity relationship diagram, or the ERD, for Classic Models. The ERD shows the list of tables present in the database along with the columns in each table and foreign key relationships between tables. First, we have the offices table, where the office code is the foreign key or the unique identifier, and there's information like the city, phone number, address, state, country, etc. Then we have the employees table. The employees table has the primary key employee number, which is again a unique identifier for each employee. And then of course there's a last name, first name, there is a phone extension, email, and there is a foreign key called office code, which allows us to determine which office an employee works at. Apart from this, there is also a foreign key reports to, which points to the employee number of a different employee. And this is used to track who a particular employee reports to. And the employee also has a job title. Then there are customers. So customers are toy or gift stores, and each customer has a unique customer number, which is the primary key. And then there's a customer name, which could be the name of the store. And then there's a contact name, last name and first name, and some other information about customers. Most customers have a sales representative, and that is tracked in the sales rep employee number column, which is a foreign key to the employees table. Next, we have the orders table, which tracks the orders placed by customers, and the order number is a unique primary key in this table. You have information like the order date, the date by which the order is required, the ship date, and then some status, whether the order was successful or not, and potentially some comments. And of course, the customer number column within the orders table is a foreign key used to track which customer placed a particular order. Now, each order can consist of several products requested in different quantities. So that's why we have the order details table, where for each order and each product within that order, you're going to have one row. So the order number and product code together are the primary key. And for each product within an order, you track the quantity ordered, price each, the price that was charged for that product, and the line number, which is essentially what position that product was in that order. Now, of course, the product code itself is a foreign key that refers to the products table, and the products have names. They belong to a product line, which is itself a foreign key. And then there is some other information about products as well. Finally, we have the payments table. Customers have a certain credit limit, which is tracked in the customer table. And when they're about to reach that credit limit, or when they've exceeded that credit limit, they can make a payment using a check. And payments are tracked using the customer number and check number. And each payment has a payment date and a payment amount. So that's the entity relationship diagram. That is the structure of the database. This is not actual data. This is simply telling us the tables and the columns within those tables. And it's always a great idea to review the entity relationship diagram of a database before you start writing queries for it. So let's see how you can set up the classic models test database locally on your computer for writing queries. So first you need to download the SQL script. So there is a SQL script which generates the database, creates all the tables, adds data into the tables. So you can open up this link here. This will take you to this SQL script. You can see here it contains some SQL statements to remove the database if it exists. Then it creates a database. Then it says you want to use the database. Then you have all of these tables being created with the different types of data, with the different foreign keys. And then you have a lot of sample information that is going to be inserted. So you can either save this and open it up in MySQL Workbench, or you can just copy this entire text and run the query. Now, of course, you need MySQL Server on your computer. So you will need to download, install, and start MySQL Server on your computer. So you can download the MySQL community server from mysql.com and install it for your operating system. Make sure that it is running. And there are different ways to verify that on different operating systems. And then once the server is running and is ready to receive requests, you need a way to send requests to the server. And that's why we have the MySQL Workbench. Again, you can go on mysql.com and download the MySQL Community Workbench. And this is a desktop application which looks something like this. And using this desktop application, you will be able to connect to the MySQL server that is running on your computer. So download MySQL Server, make sure that it is running on your computer, then download MySQL Workbench, connect it. Now it should detect your local installation automatically. If not, you can click the plus button and add the information. And once you try to connect to it, you will be asked to provide a username when you set up the connection, which will be root, and a password. So here I'm setting the password that I've created. And now we are connected to the database. Now we can run queries. So I can run show databases, for example, and you can see that it contains the database information schema, MySQL performance schema, and sys. These are all default system databases that are already present. Now here you can open up the SQL file, the file that we just downloaded, or you can also create a new SQL file and paste all this information. And then you can click this lightning button, or you can press Control Shift Enter. So if you press Control Enter, that's going to simply run one of the statements. So it's going to run a single statement. But if you press Control Shift Enter, that's going to run all the statements present in this file. So Control Shift Enter or Command Shift Enter on Mac executes all the statements. And now if we go back and we check the list of databases, you will see here that we have the classic models database. So one thing you will want to do is just use the classic models database. So I'm just typing use classic models here. And now all the queries that we run will be executed against the classic models database. So that's the local database setup, and I highly recommend following along and typing out each query on your own. So here is the problem solving approach that we'll follow. We will learn all the concepts that we're going to cover today by looking at real life use cases of these concepts. Every time we have a problem, we should first try to understand the inputs. Which tables are we interested in? What do the columns look like? What does the data look like? And we should try and understand what is the output we're looking for. What does the result look like? And how can we get to that result? Then we should try and articulate the solution verbally. You can try and write this down if you're just practicing on your own, or you can try saying it out loud to yourself. Or if it is in an interview, you can talk to the interviewer and try to communicate what you want to do to solve the query verbally. If you're working and you have to figure out something, you can talk to a coworker, you can articulate your solution verbally, and then you can construct the query step by step. So this is the approach you should be taking, and using this approach step by step, we will build some fairly complex queries. Let's now start by talking about how you can work with dates in SQL. Most datasets will have dates and times that you will have to query, that you will have to process, that you will have to filter in some form or another. And in a lot of cases, you will also need to perform some date arithmetic. So first, let's talk about the date and time data types that are available in MySQL specifically, but in most SQL distributions in general. The first data type is date, and this is the format that a date has, 2004-07-28. So there is the year, there is the month, and there is the date. Then you have another data type called time, and this is the format it has, 15, 20, 52. So this is a 24-hour format. 15 simply represents the hour 3 p.m. 20 represents the number of minutes elapsed, and then 52 represents the number of seconds elapsed. Now you can end the time string here. You don't have to go beyond 52. But if you want to track time to a higher precision, specifically if you want to track microseconds, then you can go up to 6 digits of decimal after putting a point. So you can say 52.312468, and you can track time in microseconds. Then there is the date time data type. Remember, data types are simply applied to columns. So each column in a table will have a specific data type. A column can have the date data type if you're just interested in storing dates. It can have the time data type if you just want to store a time. Or if you want to store a date and a time, then you should use the date time data type. So in this case, the date time data type can store the date in this format, followed by a space, followed by the time in this format. And of course, you can go up to microseconds. There is also another data type called timestamp, which is able to track information about the time zone. So the date time data type does not keep track of time zone. If, let's say, I insert this value 2004, 7, 28, 15, 20, 52 based in India into a cloud database, and then somebody, one of my coworkers in the US, fetches that information, they're going to see the exact same date. But if I insert a timestamp and somebody in a different country then queries for that data and then tries to display it, they are going to see the data in their own time zone. So if you want to keep track of time zones, if you don't want to manage all that manually, then you can use timestamps. Otherwise, you can use date time. Let's also try and understand the different parts that you can extract out of a date and time, because a date is a complex object. It contains the year, month, and then the time itself is also pretty complex. So how do you extract the different parts out of a date and time? Here's a question. Show the year, month number, month name, week number, day of month, weekday number, weekday name, hour, minute, and second for all the payments made by all the customers. So basically we want to extract all the different parts of this time field. So let's see how we can do that. So first I'm heading over to MySQL Workbench, and I'm going to start by typing a select star from payments just to see what the payments table looks like. So here you can see payments has a check number, payment has a payment date, amount, and customer number. And the payment date seems to be of the date time type. If you're unsure about it, you can type describe and you can type the table name. And now you can see what is the data type of each column. So it looks like the payment date is of type date time. However, you can see that the date is fine, but the times seem to be all 00 everywhere. So I'm just going to change this one particular date time. I'm just going to update it so that we can see something other than just a lot of zeros. So let me open up a new tab here. And by the way, you can use Command T or Control T to open a tab. And let me update payments and set payment date equals, so let me just copy that value. And let me just set this to 15, 23, 52. And let me set it only for the first row. So I'm going to set it only for the case where check number is this value. So that's how you update a value within a table. And let's run that, command enter or control enter. And that seems to be done. Now, if we select star from payments again, you can see that the payment date has been modified. So now let us start extracting different parts from this date time. So first, let's just get the date. So from the payment date, which is the date time, let's just call the date function to get a date. And let's just call that column date. Let's see. Great. So now we have a date column, and that simply has the date part from the payment date. Then let's just get the time as well. So payment date as time. All right, now we have the time too. Then we have several functions that you can use to get things like year, month, etc. So let's get the year. So year from payment date as year. Let's get the month from payment date as month. Now by default, the month function returns a number, and you may want a name instead. So you can also use month name. So month name, payment date as month name. And then we can get the week. You can count which week in the year this is. So you can say week, payment date as week. So it's pretty intuitive, pretty straightforward. So here you can see now we have 2004, month 7, month name July, week 30. Let's get a few more things. Let's get the day of the month from 1 to 31. So day of month, payment date as day of month. So far so good. Let's get the day of the week. So you can type weekday, and that's going to number the weekdays from 0 to 6. So Monday is 0 and Sunday is 6. So let's say weekday, payment date as day of week. Then maybe let's get the day name, the weekday name, that is done using day name. And you don't have to remember all these. You can always look these up, but most of these are pretty intuitive. Once you use it once or twice, you'll get used to them. So let's run that again. So now we have the month name. So this is July, the 7th month. We have the year 2004. We have the month number, that is 7. We have the week number, so week of year. Then we have the day of the month, 28th. Then we have the day of the week, which is 2. So Monday is 0, Tuesday is 1, and Wednesday is 2. Then we have the day name, which is Wednesday. Now let's get some information about the time. So let's get the hour from payment date as hour. Let's get the minute from payment date as minute. And finally, let's get the second from payment date as second. And here you can see that we have the time. The time was 15, 23, 52, and we were able to extract 15, 23, and 52. So just to revise quickly, we said select star, and then we extracted the date as date. We extracted the time as time. We extracted year, month, month name, week, day of month, weekday, name of the day, hour, minute, and second from the payments table. So that's straightforward. In a lot of cases, you may need to run a query in relation to the current time or the current date. So to get the current date time, you can use the now function and the timestamp functions. To test out these functions, I'm just going to type select, and I'm just going to type the name of a function. So anytime you want to just quickly test something out without actually doing a query, you can just type select and then just type the expression that you want to test. For example, if I just type select 1, you can see here it simply prints the value 1. So instead of this, if I type select now, you will see that now prints the value 2022-05-21, 14-24-53, which is exactly the time at which we are running this command. And I can just call it current date time. So you can see now I've given it the name current date time. Now, another function that you can use is timestamp. And remember, the difference between datetime and timestamp is that timestamp can also keep track of the time zone. If you were to load it back in a different time zone, then it would show a different time. So let me run the timestamp as current timestamp. Okay, I believe the function is called current timestamp. Yeah. So here is a current timestamp. So they look identical here, but if you went to a different time zone and loaded these back after storing them in a table, then they would look different. So that's how you get the current timestamp. Let's see how you can get the current date alone. So you just type current date. It's all pretty intuitive, pretty obvious. So that gives us the current date. So now we have the current date. And as you can guess, you have the current time. Good enough. So you have now in current timestamp, then you have the current date, and then you have the current time. But in a lot of cases, you may want something close to the current time, but not exactly the current time. For example, you may want to get information since yesterday or say for the last week, or maybe for the next 3 months or something like that. So that's where you have this special interval keyword. And this interval keyword can be used to add and subtract durations from a date and time. It doesn't have to be the current date and time. You can do that with any date and time, but we look at some examples with the current date and time. So let's say I want to get the date for tomorrow. So I take current date and then I say plus. So you can do date arithmetic just by typing plus, and then I type interval. I'm telling SQL I want to add an interval, a duration. And what do I want to add? I want to add 1 day. So that's how I type 1 day. And let me call this tomorrow. And now you can have this column tomorrow, and you can see it contains tomorrow's date. Let's try another example. Let's take now and let's add interval 3 month. And let's call that 3 months later. And you can see here 2022-08-21. So this is 3 months from now. If you were to change this to maybe 10 months, you would see that it's not just adding this number here, it's actually going to update the date. So let me just change this to 10 months later. And now it's going to show you 2023. And you can also do this with time. You don't just have to do it with dates. So current time plus interval 2 hour. Now, one common mistake is to type hours. That's not going to work. You just have to use the keyword hour. So SQL looks like English, but it's not English. Not everything works. You have to know how to put these things together. And let's call this 2 hours later. And there you have it. Currently it is 14:28:41. 2 hours later, it's going to be 16:28:41. So that's how you get the current date and time. And now you can try doing things like get the start of this month or get the date for last Friday or something like that. So here's what we just did. We selected now as current date time, and we can use current timestamp as the current timestamp. Then we looked at the current date function. We looked at the current time function. So this returns the data of the type date. This returns time. This returns timestamp. This returns a date time. Then we saw how to add durations using interval. So you just type plus, or you can even do minus. So you can, if you want to go back, you can use minus, and interval 1 day or interval 3 month or interval 2 hour. And remember, you have to use the singular form. You cannot use the plural form. So that's how you create dates, and that's how you move dates around. Let's look at a few ways to perform arithmetic on dates. Now, one way you can add dates together is just using plus. So you can take a date, you can type plus, and then you can use interval. But there is also a keyword to do it called date add. And in the same way, there is also a keyword to subtract intervals, and it is called date sub. So if we go back here, now I could also do something like this, date add. And here I can provide the current date, and here I can provide interval 1 day. And it's going to work exactly the same way in case you prefer this notation. And similarly here, you can also do date sub. And now this would be 10 months ago. So let's run that. And you can see here we have 10 months ago, 2021. So you can use date add and date sub in place of plus and minus. Then you have date diff. Date diff can be used to subtract two dates. So date add and date sub work with a date and an interval, but date diff works with two dates. So let's say you have two dates. Let's try date diff and let's give it a couple of dates. So let's give it 2022, 05, 21 and 2020, 03, 01. That was roughly the time when the pandemic started. So let's see how many days have passed as days since pandemic. So it looks like 811 days have passed between these two dates. So that's how you use date diff. Similarly, you have time diff. You can use time diff to find differences between times. So the time right now is current time here, current time. And let's say I had breakfast at 9 a.m. So 09, 00, 00 roughly as time since breakfast. It looks like 5 hours, 32 minutes and 25 seconds have passed since we had breakfast. Another thing you can do is add time. In case you want to add two times, you can do that as well. So you can take the current time and you want to add a specific number of hours, minutes and seconds. So you can do that. Let's try this. So add time and let's take the current time again and let's add maybe 3 hours and 5 minutes and 21 seconds to it. And you can see it has the value 173828. So we are going from 143307 to 173828, and that's how you add time. So that's how you can create older times, newer times, older dates, newer dates, given a particular date or time. Now let's look at a question where we can apply these skills. So here's the question: determine the number of days and the exact duration between the required date and the shipped date for each order. You want to determine the number of days between the required date and the ship date for each order. And we also want to determine the exact duration. Then list the orders that were shipped less than 72 hours before the required date. So if you look at the schema for a second, each order has a required date, the date by which the order is required by the customer. And then each order has a ship date, the date it was shipped from classic models. So we want to determine the difference between the required date and ship date in number of days and then in number of hours. And then we want to find out which orders were shipped in less than 72 hours before being required. So let's start by selecting star from orders. So that's the information we have for each order. So here's the required date and here's the ship date. Then we want to find the number of days between the required date and the ship date. So I'm going to use date diff, required date and shipped date. And let me just call it diff days. So here now we have the difference between the required date and ship date. And it looks like in many cases, the order is shipped well before 3 days. You can see 3, 7, 4, 5. Let's see if we see an irregular value anywhere. Okay, interesting. So here it seems like it's minus 56. So it seems like this order was very heavily delayed. And then here it seems like the order was never shipped at all. So maybe the customer canceled the order or something else happened. And there are also notes or comments to note this, right? So you can already see how this is useful. But let's maybe also find the exact number of hours. So let's find time diff. Time diff can actually work with dates. So you can give it required date and ship date. The only difference between date diff and time diff is that time diff returns hours and date diff returns days. So let's call this diff hours. And here now we have the number of hours. So that is the information that we were looking for. But the other part of the question says list the orders that were shipped less than 72 hours before the required date. So now we want to put in a where clause here. So I can put in where. And there are many ways to do this. You can use a diff, you can use something else, but here's what I'm going to do. Simple comparison. Required date minus interval 72 hours and or 72-hour, I make this mistake all the time, is less than the ship date. So if you take the required date, go back 72 hours. If the order was shipped after that, so then the required date minus 72 hours is going to be less than the ship date. And this is called required date. Let's run that. And here we have the result. So now you can see we only have the orders which were shifted less than 72 hours before the required date. Of course, some of these orders may have been delayed as well, like this one. Okay. So that's how you answer date related queries by performing basic arithmetic. So we did select star. We said date diff to get the difference between the required date and the ship date. And we call that diff days. Then we use time diff again to compute the hours between the required date and the ship date. We call that diff time. And we are doing this from the orders table. We are selecting from the orders table where the required date is less than ship date plus interview 72 hours. So this is another way of writing it. Instead of saying required date minus interval 72 hours, you can say required date less than ship date plus interval 72 hours. Next, let's talk about date and time formatting. Here's the question. Show the date and time for payments made by customers in this format. Friday, January 23rd, 2004. That should be the date format, and 3:15:23 p.m. That should be the time format. So how are we going to do that? The way I would do this is just go on Google and search MySQL date formatting. And when you open this up, it's going to take you to some tutorial and it is going to show you exactly how to use it. So here we have this date format function, and it looks like you give it a date or a date time and you give it a format, and this contains some special characters. So where do these special characters come from? So there happens to be a table that tells you exactly how to get specific parts of a date. So inside this format string, if you provide %y, then you're indicating to SQL that you want it to print the year in that position. If you provide %lowercase y, you can get the year in 2 digits. Here you can get the weekday name and so on. So you have a bunch of different things. Now in our case, we want the information Friday, January 23rd. So let's see if we can get the weekday. So the weekday happens to be %w. Okay, that's fine. Then we want the month name. So we want the full month name, that is %m. Then we want the day, but we also want 23rd. So it seems like %D, %uppercase D is going to give us that. And then we want the year. So the year is over here, which is just %y. So let's see if we can do that. So we start by saying select star from payments, start of every query. And now let's try to get the date using date format. So we take the payment date and we want it in the format %w, %m, %d, %y, and of course we want the commas between them as well. And let's close the bracket and let's call that formatted date. And there you have it, Wednesday, July 28, 2004. Let's get the formatted time as well. So similar to date formatting, format time in MySQL. Okay, so there is a time format function to do exactly this. Let's see how to get the time that we want. So we can get the different parts, H, R, etc. Or it seems like if you just put in %r, it's going to give you this format, which seems to be exactly what we're looking for. So I'm just going to use time format. I'm going to give it a payment date and I'm going to just put in %r here as formatted time. And that gives us the time as you would expect. By the way, this will also work inside here. So I could just also have just as well have done this. And that would work exactly the same way. The only difference is that now the date and time are both in the same column, but if we wanted to show the date and time in different columns, then we would create 2 different formats. So that's how you format the date and time. You say date format, you give it the column name, and then you give it the format. Then you give it a new name, the resulting column. Then you call time format. If you want to just get the time, you give it the date column, you give it a format, and that's your formatted time. The reverse process of formatting is called parsing. It's possible that in some cases you may have date in a different format. So here's a question. We want to parse the string Friday, January 23rd, 2004, 3:15:23 p.m. Let's say you have a CSV file which contains this kind of information, and now you want to insert that information into a SQL database. How are you going to convert it? Maybe first you put it into a table, and this is just a string because SQL cannot automatically parse such complex formats. So this is stored as a simple string. And then you want to take that string column and you want to convert that into a date time object. How do you do that? The way to do that is using the str to date function. So str to date, this works exactly in the opposite format. So let's take this Friday, January 23rd, 2004, type that out here. Friday, January 23rd, 2004, 3:15:23 p.m. So that's what we want to convert. That's our input string. And then let's write out the format. So we just looked at the format. The format was, we have information about the weekday, and then we have information about the month. Then we have information about the day, and then we have information about the year. Again, this is something that you can look up from the table, not something you have to remember. And let's just call this parse date. Okay. And that gives us 2004-01-23, 15:15:23. Now, of course, in real life, you will not be typing out a date, but instead there may be another table where you have these dates stored as plain strings, and you can parse out the date from that table and store it in a new column or display it in the results. So that's date parsing. We just call select str to date. We give it the name of the column that contains the string dates. In this case, we just had the single value. And then we give it the format that we want to parse, and then we provide the new name for the column, and that's it. So that's everything about working with dates in SQL. Next, we're going to look at some advanced SQL clauses. We'll start by looking at the having clause, which is a special case of group by. We'll see why it is required in certain cases. So here's a question we'll try and solve. List customers who have placed more than 2 orders on or after April 1st, 2004. Show the customer number, customer name, number of orders placed, and the last order date. Let's try and solve this step by step. So first, we are going to select star from orders just to get started. Here is the information about all the orders. Now, we want information about orders placed after April 1st, 2004. So let's get that information. So where order date is greater than 2004-04-01. Let's make that greater than equal to on or after. So far, so good. Now we also want information about the customers. If you go back here, we want the customer number, customer name as well. So the order table has a customer number, and the customer name can be retrieved from the customers table. So that would require a join. So let's join orders with customers. I'm going to give them names. So orders I'm going to call O, and customers I'm going to call it C. So this becomes where O.order date greater than such. And of course we have to join on something. So we can do O.customer number equals C.customer number. And that's going to join it for us. And now we want the customer number. So C.customer number. We want the customer name. So C.customer name. And then let's also get O.order number right now. So let's just do a join. So for the customer 103 Atelier Graphique, they've placed these 2 orders, and let's get the order date as well, O.order date. And this is the order, and this is when this order was placed, and so on. Now you can see that all of these orders are after the 1st of April 2004. So that's exactly what we're looking for. But we don't want the order number or the order date. What we want is to show the number of orders placed since April 1st, 2004, and the date of the last order. Okay, so how do we do that? So first, instead of showing the order number, if we just count the order numbers, so if we just do count o dot order number as num orders, and then if we check the max of order date as last order date, and then of course once we are doing this we also require a group by clause. So I'm going to say group by, and we can just group by c dot customer number, or you could also put c dot customer name here, but that's not required because the customer number will already ensure uniqueness. So c dot customer number is enough. So let's run that. Okay, so now we have the number of orders and now we have the last order date. All good. Now here is the last thing we need. We only want to list the customers who have placed more than 2 orders on or after April 1st. So ideally we want to say something like this: and num orders greater than 2. Let's run that. And that's going to result in an error. So what is the issue here? The error, if you see it carefully, it says unknown column num orders in where clause. So what's happening here? Let's think about it. How did we construct this query? First, we selected some columns and we filtered out the rows based on the where clause. Then we did a group by on those filtered rows. And now we want to do another filtering on the grouped rows. You can see where SQL is facing a problem. What SQL is basically trying to ask us is, do you want me to do the where first or do you want me to do the group by first? If you're doing the where first and then doing the group by, then you cannot put a condition or a filter on the result of the group by, because the group by itself depends on the where. But if you do the group by first, then you cannot filter by order date because order date is no longer present. You only have the latest order date. So by default, how SQL works is that first it applies the where clause, then you get a set of rows, and then after applying the where clause, after filtering the rows, it applies the group by. And now after applying group by, there is no more order date column left. And now if you want to have a condition to be applied to filter rows after grouping, that's when you use the having clause. So now what you say is having, and once you say having, you can now apply filters on the columns that were created after grouping as a result of the grouping. So now here we can say having num orders greater than 2, and I can run that. And now you can see here, we are only looking at the customers that have more than 2 orders. And of course you can do things like order by num orders descending if you want. So all of that is still the same. The only change here is that if you want to apply certain conditions on the column that is a result of an aggregation, you cannot do it in where, you have to do it in having. So that's what our query looks like. And here now we have the list of all the customers who have placed a whole bunch of orders, and it looks like Euro Plus shipping channel places a lot of orders, and especially since 2004, April 1st. So here's what we did. We selected the customer number and we selected the customer name, and then we counted the number of orders as num orders. We counted the order numbers, but we could just count star, which is the number of rows as well. Then we took the max of the order date, and that is the last order date. And all of this information was extracted from customers joined with orders on c.customer numbers equals o.customer number, where the order date is greater than 2004-401. And of course we were grouping by customer number because we want these metrics per customer. And we wanted to only look at customers who have placed more than 2 orders. So to apply a condition on num orders, we needed the having clause. And that gave us exactly what we were looking for. So that's group by and having. Next, we'll talk about something called common table expressions. As you write larger and larger SQL scripts, you will need to take the result of one query and then use it as the input to another query. One way we've done that is by having subqueries, where you have a query within brackets inside a query. But another nicer, neater way of doing that is something called a common table expression using the with clause. So here is how it works. You say with, and then you give the name to a query that you're going to run. And you can also optionally provide the list of columns that you're going to get out of the query. So you can give names to each of the columns, and then you say as, and then within brackets, you provide the query that you're going to run. So this can be any SQL query, and then the result of that will be captured, conceptually speaking, and can be referred to by this name. And you can also pick columns out of this result by the names provided in this column list. And this is optional. By default, it will be inferred based on the result of the query. And now you can use it within a select, insert, update, whatever kind of statement you want. So you can say with name column list as query, and then you can say select star, and then anywhere within this query, you can use the CTE underscore name, the name that you've given to your common table expression, and process it. That's all there is to it. It's just a nicer way of separating multiple queries and giving one a name and using it in the next query. So here's one example that we look at. Identify the top 5 sales representatives based on the total amounts of the orders that were shipped in 2003. So we've reached the end of the year. We want to reward the 5 best performing sales representatives. So we need to look at the orders that were successfully shipped in the year and find the total value of all those orders for each sales representative. Remember, orders are placed by customers, and then customers have a sales representative. And we want to output the employee number, the first name, the last name, and the total sales they were responsible for in the year 2003. So let's see if we can write this. We're going to build this step by step. So first of all, we are concerned with orders. So let's start with select star from orders. We are only concerned with orders that have been shipped. So one thing you can do here is add a where clause. So where status equals shipped. And now we are only seeing shipped orders. There are also other kinds of orders. If you don't have this, you can see that some orders are cancelled as well. There are very few of them, but yeah, you can see here there are a bunch of different kinds of orders, but we are only looking at orders that were shipped, which indicates successful orders. Then we only want to look at orders from the year 2003. So let's put in an and let's say year ship date equals 2003. Now this could depend. You might want to look at order date, required date, but I'm just going to look at the ship date. So the ship date is 2003. Now we're looking at the orders with the ship date 2003. Now we are really only interested in the order value. So how do we get the order value? I'm going to give this a name, and then I'm going to join this with order details, OD. If we look at the schema here, we have orders, and each order has a bunch of order detail rows, and each product has one row in order details for that order. And for that product, we can determine the quantity ordered and the price each. So if I go in here and I join orders with order details, and now this can be o.status and this can be o.ship date. Now instead of getting everything, I can try and get o.order number, and I'll also keep the customer number because the customer number will be useful later on to get the sales representative information. And now we want to find each order detail row. For that order, we want to multiply the quantity ordered by the price, and then we want to sum them up. So I'm going to say sum quantity ordered, and this is going to come from OD, order detail, multiplied by OD dot price each. So for each product, we're going to compute the quantity ordered and price. We're going to sum them after grouping by O dot order number. There we go. And let's call this order value. Okay, let's run that. Oh, customer number, there's a typo. And of course we forgot to join on. So that's why these values seem a little bit off. So O dot order number equals OD dot order number, right? So for each order detail, we are going to join on the order number column. And now we have this information. So we are selecting order number, customer number, and the order value, which is the quantity ordered times price each, summed over all the rows grouped by orders. And this is obtained by joining the orders table with the order details table. And we're only looking for the status shipped, and we're looking for the year of ship date 2003. So now we have order number, customer number, and order value. Now this is something that I can then use in my next query, where I can try to get information about the sales representative who was responsible for this customer. So here's what I'm going to do. I'm going to call this order values, and I'm going to open as here, and let's put all of this. Let's just give that a spacing so that it's easier to understand. Let's get rid of the semicolon. So with order values as this, now I'm going to write a select query here. So let's first just say select star from order values. And we're currently doing the same thing. But let's now get information from the customers table as well. So let's call this OV, and let's join this with customers. So customers C. And let's join this on ov.customer number equals c.customer number. And let's see that it's called customers. So now we have information about each customer as well. So now for each customer number, we also have the information about the customer, but we want information about the sales rep. So we want mainly the sales rep employee number. So I'm going to join this once again. So I'm going to say join this with employees, and let's call this E on c.sales rep employee number equals e.employee number. Okay, so now we're doing a three-way join. We joined order values with customers. Now we're joining customers with employees so that we can populate the employee details based on the sales rep employee number. Okay, now of course we probably don't want all this information. Let's just keep the order number. Let's keep the customer number. Let's keep the customer name. So c.customer name, and then let's keep the c.sales rep employee number. And from the employee table, let's keep the last name. And from the employee table, let's keep the first name. So we have all these three tables. One is the order details, the common table expression. Then second is the customer table, from where we are just going to keep some customer information. And then all of this is then put together. So let's run that. So here we go. Now we have the order number, and let's also keep the order value, ov.order value. So now we have the order number, customer number, and order value. All of this is coming from here, the order values common table expression. Then we have the customer name. Then we have the customer sales rep employee number. So for the customer, we get the sales rep employee number. Then by joining with the employees table, we have information about the last name and first name. Now, of course, the question asked us to find the employee number, first name and last name, and total sales in 2003. So we're not really interested in the customer name, and we're not even interested in the customer number, and we're not even interested in the order number. These were all useful to perform the joins. We're not even interested in the order value. What we are simply interested in is the sum of the order value column. So ov.order value. So let's just sum that as sales. Let's just call that sales. And we'll then also need to group by, because for each sales rep, we want to combine all the rows and sum them. So I'm going to group by c.sales rep employee number. Okay, let's see now. So now we have a sales rep. Now we have the last name. Now we have the first name, and then we have the total sales they were responsible for. I'm also just going to round this to 2 decimals. And now we have the sales rep employee number, last name, first name, and sales. Now we also only want the top 5. So first let us order by the sales, and let's limit to 5. And of course we want to order by the sales descending. Okay. And that gives us this information: Leslie Jennings, Gerard Hernandez, Pamela Castello, and so on. So that's pretty much everything we need to do here. And now we have information about the top 5 performing salespersons for the year 2003. So let's just recap that. That was a lot going on there. So first we created a common table expression called order values, where we selected the customer number, order number, and then we also selected the total order value, by taking the sum of the quantity ordered multiplied by the price each for each row in the order details column. So we had to join the orders table with the order details table, and we joined them on the order number. And we only looked at the orders where the ship date was 2003, the year of the ship date, and the status of the order was shipped. And we grouped them by order number because for each order we wanted to get the total order value. So that was our common table expression. That's what we started with. Order values, the common table expression had the customer number, order number, and the order value. We could then use it in the next query. So this is all part of the same query where we selected the employee number, employee last name, employee first name, and then we took the sum of order values and we added that as sales. And here we were joining order values first with customers on the customer number, and then we joined the resulting table with the employees table to check the sales rep employee number of the customer and match that against the employee number of the employee. And then we grouped by the sales rep employee number because for each sales rep we wanted to get the total sales. And then we ordered by the total sales for each sales rep in descending order, and we limited that to 5 results. And that gave us the top 5 performers in the year 2003. So now we are doing queries that are going into 2 pages that are going very long. But remember, you always start with a select star statement and then you slowly build it up step by step. And by the way, this is not the only way to solve this question. There are probably 6 or 7 different ways you can approach this question. But the important thing is that you build it step by step and you have full understanding of what's going on at each stage. Next, let's talk about union, intersection, and difference. These are concepts that are used to combine the results of 2 or more queries. So let's say you run a query and it returns 10 rows and there are 3 columns in the result. And then you run another query, maybe on a different table, and that returns 15 rows, but they have the same 3 columns. So every time 2 results have the same columns and you want to add those 10 rows and those 15 rows together to get all 25 rows, then you can perform something called a union. So this is what conceptually it looks like. You have the results of a query, you have the results of another query, and a union would take all those results and then show them all together. This is different from a join. In a join, you are combining 2 tables based on a column. But in a union, what you're doing is you're just taking the rows from the first table and then you're taking the rows from the second table and putting it below the first table, and you're just getting more rows. When you do a join, you don't necessarily get more rows than either of the tables, but in a union, you basically increase the number of rows while you keep the number of columns the same. So that's the difference between union and join. So that's one. You had 10 rows and 15 rows, both with the same 3 columns, and you get 25 rows. So that's union. The other is intersection, where one query gave you 10 rows, one query gave you 15 rows. You just want to retain the common rows from the 2 queries, exactly the same common rows. And then you would maybe be left with 3 or 4 rows that are common between the 2 results. That's the intersection. And finally, there is the difference. You have 15 rows from the first query, and then a second query returns 10 rows. If you remove the common rows from that query, then what you will be left with is the difference. So that's union, intersection, and difference. And now let's look at an example of union. List cities where classic models either has an office or a customer. So we want to find the cities where classic models has an office or a customer. Let's start by looking at offices. Select star from offices. And these are all the offices that classic models has: San Francisco, Boston, NYC, etc. So we're just interested in the city. So I'm just going to keep the city, maybe also keep the country, and maybe I'm also going to keep the state, just so that we have fuller information, because cities across different countries may have the same name. So city, state, and country. So these are all the places where classic models has offices. Then let me list the cities where classic models has customers. So let me select star from customers. These are all the customers. Again, let me just keep the cities. So city, state, and country. So these are all the cities where classic models has customers. So we are operating on 2 different tables. We have the offices and then we have the customers. Now we want to get the list of all the cities where classic models either has an office or a customer. Basically, you're indicating presence in some sense. How do we do that? We can take this first query. Let me take that and let me put that into a bracket, and then I'm going to type union, and then I'm going to put a second query also in brackets. And for this to work, both of the queries should have the exact same columns and the exact same column names. Otherwise it's not going to work. So in this case, they do city, state and country from offices and customers. So we are taking results from two tables and now we are adding them together. You can see here that these get added together. Something that we may want to do is maybe order by city name. So let's order by city and let's see if we have any duplicates here. So there may be certain duplicates. So what might happen is when you take the union of two, there may be certain duplicates. So you can either say union all if you want to keep the duplicates, or you can say union distinct if you want to skip the duplicates. And this way you will not have any duplicates left. Okay. Now we don't really have state for a lot of these. So it's just city and country for most of them, but looks like we've been able to extract information about all the cities and countries. Now, of course, if you want to count this, we can actually put all of this into a bracket and we can say select count star from, and we just need to give it a name. So it looks like in total, we have about 98 cities that show up in the database. So that was union. Let me do away with this count. So what we did was to select city, state and country from offices, and then we did a union and we only wanted to keep the distinct rows, and then we selected city, state and country from customers. So you don't necessarily need a bracket here, but it's always a good idea to put additional brackets just to make sure things are clear. But you do need a bracket here outside because you want to apply order by onto the entire union combined query. So that's union. Now here is an exercise for you to work on intersection. List the cities where Classic Models has an office and has at least one customer. So that means you want to have an office and a customer. In a lot of variations of SQL, for example, Microsoft SQL Server, there is an intersect operation, which is similar to union. So you can simply replace union with intersect, and that will do exactly this for you. It's going to only keep the rows that are common, but MySQL unfortunately does not have intersect. So you'll have to use some tricks. For example, you will have to use something like select city, state, country from offices where city in, and then you will maybe have to give another query here. Select city from customers. And you could do something like this. And this is just the list of the places where Classic Models has an office and also has customers. Here is another. List the cities where Classic Models has an office but does not have any customers. So here you could say something like not in. So maybe these are the offices that we may want to consider shutting down because there are no customers here, or maybe relocate to a different city in the same country where there are customers. These are different ways to achieve union and intersection. Of course, we are only looking at one column here, but if it gets more complex, you may have to do some joins, etc. But that's the basic idea of union, intersection, and difference. You can combine rows from multiple tables, multiple queries together. Next, let's talk about the case clause, or the case when then else clause. This is used to create a new column in the result based on various conditions applied to an existing column or multiple existing columns. Now the best way to illustrate this is through an example. Classify customers based on the number of orders they've placed as new, which means they've placed 0 orders, one time, which means they have placed at least one order, repeat, which means they've placed 2 orders, and loyal if they've placed more than 2 orders. Okay, so let's try that out. So first let's select star from customers. That's how every query starts. Great. Now we have information about customers here. Now we want information about orders. So I'm just going to join this straight away with orders. So join orders O. And I'm going to join on, and it's going to be a left outer join because I want to keep customers who have not placed any orders also. So left outer join orders O. on c dot customer number equals o dot customer number. Okay. And let's run that. And already now you can see that for each customer, we get multiple rows for each order they've placed. And if I keep scrolling down and if I keep checking here, you will find that there are certain places where the order column is null. So the order column is null. What that means is that this particular customer has not placed any orders so far, right? So that's why we've done a left outer join. If we had just done a normal join, then that would not have worked. But a left outer join ensures that we keep customers even if they have not placed a single order. Great. So now we have identified orders for customers, but we want a count of orders. We want to count the number of orders they've placed. So let me just keep c dot customer number and let me keep c dot customer name. And let us sum, or actually let us count the order number. So o dot order number. Now here we should be doing a count order number and not a count star, because we don't just want to count the rows, we want to count how many order numbers there are. And if the order number is null, then that will not get counted and we want the count to be 0. So that's why count order number as num orders. And let's just add a group by clause here, group by c dot customer number. Okay, let's run that. Okay, so now you can see that in the cases where there were no orders, count of order number, o dot order number, is going to exclude nulls. So that's why we got a count of 0. And in the cases where there were orders, we got the count of the number of orders that people had placed. So again, count star will not work here. So count star, you see, it returns 1 because it counts the number of rows. We need to count non-null order numbers. That's why we have o dot order number here. Great. So now we've counted the number of orders, but now what we want is we want to show a new column called customer type, and it should have the value new if the number of orders is 0, and it should have the value one time, repeat, or loyal based on 1, 2, or more. And this is where we can use the case statement. So we can say case, and once again, I'm just going to use count o dot order number to get the same value. But now, instead of directly using this value, I can say when this value is 0, then set the value new. When this value is 1, then set the value one time. When this value is 2, then set the value repeat. And else set the value loyal. And that is the end. And then as, and then here we just call it customer type. Okay. So this is the format of the case statement. You say case and then you give it some expression, which could be a column or could be an operation on a column, like a count. And then you say when, and you check this value against this expression, and then you return this. Okay. So it goes through each of these, and if it doesn't match any of these, then it is going to return whatever you've provided in else. So let's check that. And here you can see now we have the customer type added. And let's order this. So let's do order by num orders. So these are all the new customers. Now you can see how this is useful, because now you can look at all the customers who are new, and you can maybe call them and ask them why they've not placed an order yet, if they've signed up with you as a customer. And you can maybe also look at some of the loyal customers, and these two seem to be really loyal, and maybe just give them a discount of some kind to make sure that they order more from you, right? So you may want to handle different types of customers in different ways, and that's what the case statement is going to allow you to do. So that's one. So here's what we did in the case statement. We say select customer number, customer name, and the count of order number. And we have a case statement on the count of order numbers. When it is 0, we say new. When it is 1, we return one time. When it is 2, we return repeat. Else we return loyal. And we call this resulting column customer type. And we're selecting that from customers left outer join orders. So it's left outer join because we want to keep customers who have no orders. And then we select on c.customer number equals o.customer number. Then we can group by customer number, of course, because we want to combine and count the orders for a specific customer separately. And then we can order that by the number of orders ascending or descending as we want. So that is one way to use the case statement. Case, expression, when, value, then something, else something. Now, one use case of case is to do something called pivoting. And here is an example of this. Show the number of shipped, on hold, in process, resolved, cancelled, and disputed, and total orders for each customer. So the order status can be shipped, on hold, in process, resolved, etc. And we want to show that for each customer, we want to show all of these counts. So how do we show that? Let's start by selecting star from customers. And let's also join the orders table on customers dot customer number or c dot customer number equals o dot customer number. Okay, so this is the information here. We are interested in looking at the number of shipped orders, the number of total orders, and the number of resolved orders. So total is actually pretty simple. So we can simply do group by customer number. And here we can say c dot customer number, c dot customer name, and just count o dot order number as, and let's call that total. So I'm just going to, I can just call it total. So these are the total orders. Now let's try to get the shipped orders. Okay, how can we get the shipped orders? So here's a trick that we're going to apply. I'm going to use a sum and I'm going to call this shipped. I'm going to use a case statement here. So case o dot status equals shipped, then 1. Oh, actually, no. Case when. So here's the other way to use case. You can say case and then without giving an expression, you can say when, and you can give a condition here. Case when o dot status equals shipped, then 1, else 0. So what we are saying is look at an order, look at the status of the order. If the status of the order is shipped, then return 1, else return 0. So for each order, along with the order information, we will now have a 1 or a 0 under this column called shipped. And then we are summing them up. So we are summing up all the ones, and we'll get a 1 every time an order has the status shipped, and we'll get a 0 every time an order has the status something other than shipped, right? So let's try that out. End. And here you go. So now what we are seeing here is you can see for this customer that they have a total of 4 orders, La Rochelle gifts, but only 3 of them have been shipped. And if you want to verify this, we can just select star from orders where customer number equals, what is the customer number here? 119. So where customer number equals 119. So you can see here they have 1, 2, 3, 4. They have 4 orders, but out of those 4 orders, 1 of the orders is in process. And that's why it did not show up in shipped. Because, by the way, you can also take this case statement and put this here. So if I just put comma, case, and let's remove that to status. Yeah. So you can see here, this case statement simply puts a 0 or a 1 based on, it puts a 0 or a 1 based on whether the order was shipped. So if the order was shipped, it was 1, and if the order was not shipped, then it was 0, right? And we are just summing that over, and that's why it just gives us the total count. Now, this is for shipped. So I think the same thing we can do for in process. And that's in process. So if you want to have a space in the column name, you can use quotes. Otherwise, you can just do this without spaces. So that gives us in process. And the same thing we can do now if we want to check cancelled. And so on, right? So there are many such statuses. So you can check each of these statuses. So what we are essentially doing is we're taking the order column with the order status column, the values of the status column, and we are converting them into rows. And this, we are taking the values of the status column, the unique values, and we are converting each of them into individual columns and doing counts for those. So if you're familiar with Excel, this operation is called pivoting. So if you need to perform a pivot, what's called a pivot table in MySQL, then you would have to use a case statement to achieve it. Okay. So that's how you perform pivoting in MySQL. You can see here that we have all the different variations showing up here. So here's what we do. We select the customer number and customer name, and then we sum the case when status is shipped, then 1 else 0 as shipped. Similarly, we do that for on hold. We do that for in process. We do that for resolved, cancelled, disputed, and we also count the total. So we have taken all the unique values in the status column, and we have created a new column for each one of them. And we have done the sum to show the total counts for each customer. And of course, we did that by joining orders on customers. Now, one special thing I want to show you here is something called natural join. So what you can do is if you say orders natural join customers, it's going to automatically join on the column that is common between them. Okay. So that's how you create a pivot table using case. So here's an exercise for you. Classify products based on total units shipped as bestseller, which is where if the product has shipped more than 1,000 units, popular if the product has shipped 1,000 to 1,500 units, and infrequent if the product has been shipped less than 1,000 units. Okay. Then after this classification, list the number of unique products in each of these categories. Okay. So this will require you to first do a case statement, and then maybe you can either use some sort of a common table expression, or you can just apply the pivoting technique that we just discussed to show the list of unique products in each category. Next, let's talk about some advanced SQL statements. So apart from querying a database, there are some other types of SQL statements that can be used to perform code reuse essentially. And we'll start by looking at stored procedures. So stored procedures allow us to reuse a query without having to retype. So if there is a query that you are running very often, maybe every day you are getting up and running a certain query as soon as you get back to work, you might put that in a notepad somewhere, or you can actually just store that query within the database itself. And we'll look at how to do that. And a stored procedure has the additional benefit that it can take 0 or more inputs. So you can configure an input, and the entire query that you have saved is going to be executed using the input or the inputs that you provide to the stored procedure. And the stored procedure is just like a normal SQL statement or query. So it can return a result which consists of a list of rows, or it could just contain a list of values, or it could even just be a single value, right? So any statement that you can run in the workbench can become a stored procedure. And that's basically what a stored procedure is. So we'll try to understand stored procedures by looking at an example. Here's the example. Create a stored procedure So here's the question. Create a stored procedure to list all the orders for a given customer. So given a customer name or customer number, you want to list all the orders for that customer. Along with each order, you also want to find the order value. So this is something that we have been implementing over and over. So it might be a good idea to maybe just encapsulate it in some format so that we can reuse this, right? So we will create a stored procedure to list all the orders for a given customer, given their customer number, and show the total order value for each order as well. So let's start constructing the stored procedure one by one. The first thing you to do before creating a stored procedure is to first figure out what is the query that you want to run. So we want to show maybe information like a customer number, a customer name and customer number, and then maybe some information about the orders. So let me just select o.order number. Actually, let me start by selecting star from orders. So select star from orders. So this is the information about orders, right? Now we want to get the orders for a specific customer number. So I am going to add in a where clause here, where customer number equals, let's see, let me just check the customer number 181. So let's just do it for customer number 181 first. Okay. And these are the orders. And for each order, we also want to show the order value. So I'm also going to just add a join statement here. So I'm going to join, I'm saying orders O, join order details OD on O dot order number equals OD dot order number. Great. And we want the total order value. So let me just return the O dot order number, and let me return O dot customer number, and let me then return sum of OD dot, let's see here. So we have the order details, which contains one line for each product contained in the order. So we are multiplying the quantity ordered with the price. So OD dot quantity ordered with the OD dot price, right? And let's just call that order value. It's called price each, and we might just want to put O dot customer number here. Okay, and of course we'll need a group by. So group by O dot customer number. All right. I guess there's still some error here, so I'm just looking through the error here. Yeah, let's also group by, let's group by order number actually. Group by order number, not customer number. Yeah. So we group by order number, and we compute the total order value. So here are the three orders placed by customer number 181, and the order values are these, computed by taking the sum. Okay, so this is something that we are going to run over and over again. So let's do this. Let's convert this into a stored procedure. So how do we convert it into a stored procedure? So the first thing we have to do is type create procedure, and we have to give it a name. So orders with value. Okay, and then we can provide inputs. So it's going to take an input, and this is not compulsory. You don't have to provide inputs, but we are going to look at an example where we are providing inputs. So let's call the input variable customer number. So this is something that will be provided when we call the orders with value procedure, right? And this is going to be an integer. And then below this we say begin. Then it is just convention to add some indentation. And then at the end of the statement, or even multiple statements, you can say end. And now this is the syntax you need to create a procedure. So if we say create procedure orders with value in customer number int, and what we can say is instead of checking for customer number 181, we can check for the customer number that was passed in, right? So if we just try to run this, it is going to throw an error, because by default, SQL, when it sees a semicolon, it treats that as the end of that statement, and it tries to execute everything before the semicolon. So that makes it a bit tricky, because inside this procedure, we can have multiple statements. So we need to have semicolons, but as soon as SQL sees a semicolon, it is going to try to execute that statement. So that's why what we do almost 100% or 100% of the times you're creating a stored procedure, you'll need to use semicolons inside. So what you can do is you can first use a delimiter statement, and you can temporarily change the delimiter. So you can, let's just change the delimiter to anything other than semicolon, right? So the delimiter is simply the symbol that is used to detect the end of a statement and perform execution. So what we are doing here is we are saying, let's change the delimiter to $. Then let us create the procedure. And after creating the procedure, inside the procedure, we can use semicolons, and that will not cause immediate execution. And at the end of the procedure, let's close it with the $, right? So we're basically saying that instead of semicolon, use $, to treat the end of a statement. And we are putting the $, at the end of the create procedure statement. Okay. And then once we have done that, once we have defined our procedure, we can change the delimiter back to semicolon. Okay. So this is just because create procedures were added into SQL a little bit after where the implementation of basic SQL functions. So that's why this is sort of a trick that you have to do. You have to first, anytime you're creating a procedure, you have to first change the delimiter, and then after changing the delimiter, you need to then, you can use semicolons as you like within the procedure, and then you can just end with that delimiter, and then you reset the delimiter back to semicolon. Okay. And now you will be able to create this procedure, orders with value. So now when we run it, it runs successfully. So orders with value, we now have created the procedure. Now to use the procedure, we can say this, we can say call orders with value, and we can then give it a customer number. So let's give it a customer number. Let's see. Let's give it a customer number 119. Let's say 119. And let's run that. And that prints all the orders placed by the customer. So that prints all the orders placed by the customer with the customer number 119. You can see 119. These were the orders they placed, and these were the order values. Now you may want to change the procedure. So you may want to maybe round it. So now we can go into this and we can add a round statement, and let's put the rounded value here, and let's run that. And that's going to throw an error, because if a procedure already exists in the database, then you cannot create a new procedure. You have to delete the existing one first. So you can say this, drop procedure orders with value. And we can say if exists, so that this does not throw an error. So drop procedure if exists order with value. And now what we do is first we are deleting all the orders with value if it exists. Then we are creating a new procedure orders with value. And now it has a rounding logic inside it. And now we can go in here. And now when we run orders with value 119. Okay, well, I need to do Command Shift Enter to run all the statements. So now first we are deleting the procedure orders with value, and then we are creating the procedure orders with value once again. So again, because these are multiple statements, you need Command Shift Enter or Control Shift Enter to run it, or you can also just press this button. And now if we come back here and call orders with value, you can now see here that we have customer number 119, order value is now rounded to 2 decimals. And now you can try changing the customer number. So let me just select star from customers. Let's try maybe customer number 112. So customer number 112 here, I am just simply going to call customer number 112. And these are the orders placed by customer number 112. You can change that further. So let's try maybe customer number 128. So let's see, customer number 128. So you see the benefit of stored procedures. Once you have created a stored procedure, then you can keep reusing that query and you can keep passing different inputs into it. So now this is your own special keyword that you can use, and you don't have to write down that query somewhere else to figure it out. So that's how you create a stored procedure. You say you first change the delimiter to something else. It could be $, whatever you want to change it to. Then you call create procedure, you give the name of the procedure, you give a list of inputs, and each input you have to specify a type. Then you say begin, and then you include one or more statements. In this case, the statement is to get the order number, customer number, and maybe even order date, and the order value from orders join customers on order number, and where customer number is matching the input variable customer number, right? And you group that by order number, of course, to get the order value per order. And then you call end, and then you end with the delimiter that you had set. And then finally you change the delimiter back to semicolon. So that's how you create the stored procedure. Then to use it, you just say call, and then you give the name of the stored procedure, and then in brackets you give the inputs that you want to pass. Then if you want to delete it, every time you want to update a stored procedure, you will first have to delete it. So you can say drop procedure if exists orders with value. And if you want to list it, so to list procedures, you can just say show procedure status. So you can just say this, show procedure status. And you can say, normally you provide where here and you provide the name of the database. Otherwise it's going to show you a lot of internally stored procedures. So classic models is the name of the database. And let's run that. And you can see here we have orders with value as a stored procedure inside classic models. So that's how you see the list of stored procedures. And you can also see who has defined it as well. So you say show procedure status where DB equals name of the database. Another way to reuse code is something called stored functions. A procedure allows you to reuse an entire statement, but a function allows you to reuse logic within a specific query. So if you have a small piece of logic and you want to reuse that inside other queries, then that's when you create a function. A function, just like a procedure, accepts 0 or more inputs, but a function is different from a procedure in the sense that it always returns a single value, because a function is supposed to be used inside a query. And that's why it should always return a single value. So think of a function like the built-in functions, count, sum, etc., which take one or more inputs and return a single value. Okay, so let's look at an example of let's look at an example of a stored function. Create a stored function to classify payments as small, which are up to 10K, medium, which are $10,000 to $50,000, and large, which are over $50,000. Okay. And using the function, show the total number of payments of each type. So let's try to implement this function. So we'll start by simply solving this problem first. How to classify payments as small, medium, or large. So the logic here is if the payment is smaller than $10,000, then you classify it as small. Otherwise you classify it as medium. Otherwise you classify it as large. Okay. So the way to start a function is again similar. You say create function, and then you give the function a name. So I'm going to call my function payment size, and I am going to, this function is going to take an input amount, and this input is going to be numeric. And then you also have to specify what this function returns. So this function is going to return the value small, medium, or large. So these are strings basically, or characters. So I'm just going to say varchar 10. So it's going to return a character up to 10. It's going to return a string containing up to 10 characters. And then we say begin, and then we end the function with end. Now, one other thing we have to do is we have to specify whether our function is deterministic or non-deterministic. So deterministic means every time a particular input is given to a function, does it give the same output or not? So in this case, our function is deterministic. So if your function is deterministic, you can specify this in that SQL will perform certain optimizations, but if not, you can skip it. So the idea is that when you say deterministic, each time an input is given to a function, it will return the same output. You're telling that to SQL, so it can perform some optimization or caching. Okay. So now let's write the body of the function. Now inside a function, you can declare variables. So this is how you declare variables. So declare size. So I'm declaring a variable called size, and it is going to be a 10 character string. And then inside a function, you can have multiple statements. So you can put semicolons, and you can do that multiple times. But what that means is, because we are using semicolons inside this function, we'll need to change the delimiter. So I'm just going to change the delimiter to $, and I'm going to put that at the end. And then at the end of the function definition, I'm going to change the delimiter back to semicolon. Okay. So now we've declared a variable called size. And now we can just do something like this: size equals small. And then finally in a function, you have to return a single value. So you can just say, actually you have to say set size equals small, and then you can simply return size. Okay. And right now, and of course we need a semicolon here as well. So right now our function is fairly straightforward. It is always returning small, but let's just run this. Let's just create this function. So let's do Command Shift Enter to create this function, and the function is created, and let's use this function. So I'm going to say select star from payments. So that's the payments. And now we are going to add the payment size here as well. So I'm going to use the function payment size, which is now stored, and I'm going to use it on the amount, and I'm going to call this result payment size. Okay. Yep. So you can already see now how easy it is to use a function. So just like we were using count, or we were using like the date or time functions, so similarly here we have this function payment size. It takes an input amount and it returns some output. In this case, the output is always small. Okay. Now what we want to do instead is we want to have some kind of conditional logic. So we want to have this conditional logic, and the way to do this inside a function, only inside a function, and also inside a procedure if you want to do it, is using an if statement. So just like within a statement you can use case, within a function you can use an if statement. So here's what an if statement looks like. You say if, then you provide some condition. So we'll just provide a condition here, and then you say then, and then you do something. And then you can say else if, and then you provide another condition. Then you can say then, and then again you can do something. All of this is not valid code yet. And then you can say else, and then again you can do something. And then you say end if. So that's how you create an if statement. Okay. So let's remove this set size small, and let's do some conditional checking on the amount. So here now we can say if amount is less than or equal to 10,000, then we set size equals, we set size, the variable that we declared, equals small. Then else if, so we can have any number of else if conditions like this, if, else if, else if, but we just need the one here. Amount is, so it's, the else if will be executed only if the previous if is not executed. So else if amount is less than 50,000, then we set size equals medium. Else we set size equals large. Okay. And then we have an end if. So that's what the if else, else if else statement looks like. So if condition then something, else if, and you can have multiple statements here if you want, else if condition then something, else if condition then something, you can keep going. And finally you have an else, and then you do something else. And finally you can end it with end if. And so that's what we are doing. And then we are returning the size. So let's try to run that. And this will fail because this function already exists. So just like procedures, we have to first drop it. So drop function if exists payment size. Let's run that. And then the function got created. So first we are removing the function and then we are creating the function. You can check using show status. I believe show function status where db equals classic models. You can see here payment size, the function exists. If you deleted it, it would not exist. So now the function is created and we've updated the logic here. Now we can use it here. So here now we can say payment size is small, medium or large for each of the payments, depending on whether they fall into one of these categories. But the question said using the function show the total number of payments for each type. So let's just do group by payment size. And let's do a count star here. So let's get payment size and then let's get count star as payments. And let's run that. Or let's call this payment count. So count star as payment count. And that gives us that there are 42 payments that are small. And by small, we mean less than or equal to $10,000. There are 189 payments that are less than or equal to $50,000, but not less than $10,000. So between 10,000 and 50,000. And then there are 42 payments that are greater than $50,000, so which don't fall into either of these categories. And that's how you use a function. So once you define a function, it'll be there in the database. You can close MySQL Workbench. You can come back. You don't have to execute this again. Once a function or a procedure is saved in the database, it's there in the database and it's going to get executed whenever you call this keyword. And if you try to redefine a function that already exists, you're going to get an error. So you can use the drop function to remove it. So we first, to create a stored function, we change the delimiter, then we call create function and we give the function a name. We give the list of inputs in brackets. Then we declare what the function returns, the return type. And remember, a function can take multiple inputs, but it should return a single output. And we can also specify that the function is deterministic, which means given an input, it will return the same output. Then we say begin, and then if we want, we can declare some variables, so we can have multiple statements. We use the if statement for conditional logic. So we say if condition then we can write some code. Else if condition then we can write some code. Else run some code, and finally we end the if. And after several lines of logic, we can then return a value and end the function and reset the delimiter. So that's how you create a stored function. Now a stored function can operate on a value, but a stored function internally can also interact with the database. So that's something that you have to decide. Typically, it's not a good idea to interact with the database in a stored function. You should just have some piece of logic, because when you use the function again within a query, that can trigger many queries and that may be unsafe. So that's why generally functions are suitable for small pieces of logic like this, and procedures are suitable when you want to make a query to the database. Okay. So here's how you use a stored function. You say select payment size, which is the name of the function. You give it the input column name, and the function is going to get applied to each value within that column. And then you say as payment size, so you can give the resulting column a name. And here we have then taken the payment size and grouped by it, and then added the number of, or counted the number of rows for each payment size to return the summarized result for each payment size. So that's how you use the function. Very straightforward. To delete a function, and if you want to update a function, you'll first have to delete it. You call drop function. So drop function if exists payment size, and that's going to remove the function. Then to list the functions available in your database, you say show function status where database equals database name. So that's all about stored functions. Now here's an exercise for you. Enhance the orders with value stored procedure that we had earlier to list the orders for all customers if the provided customer number is null. So we worked with stored procedures earlier and we provided a customer number, and the customer number, if it was null, then the customer number was a number, and using the number we only showed the orders for that specific customer. Now that you've learned about the if else if statement, if the provided customer numbers to the stored procedure orders with value is null, can you output the list of orders for all customers? So that's a challenge for you. I will let you work on that. Okay. Finally, let's talk about this topic called recursion. You will probably almost never need to use this. There may be some use cases, but they're going to be very rare, but it's still, just for completeness, it's still a good thing to know in case it ever comes up in an interview or at work. Then you can maybe just look this up, or maybe you should have some introduction about it. So recursion is a general technique in programming. When it comes to SQL, recursion refers to the creation of a query that references itself. So the query starts out with an initial value or an initial row of data. Then the next value is computed using the previous value. So first it starts with an initial value. The second value is computed using the first value. The third value is computed using the second value, and so on. And the query keeps running till it keeps getting valid values. And the query ends if the computed value is null, right? So the logic of the computed value decides when the query ends. So that's recursion. And I know this may seem confusing right now, but we are going to look at a couple of examples that will shed some light on how recursion works. So a recursive query is expressed as a common table expression with this special keyword recursive. So you say with recursive, and then you give it a name, the common table expression, you give it a name. And then you say as, just like this. And of course you can also have column names here if you want. And then inside brackets, first you write the initial query, the query which is used to retrieve the first value or the first row of data. And then you say union all. So this is the union statement which basically takes the results of two queries and combines them, except in this case, because it's inside recursive, it's going to keep running over and over. And what do you union the initial query with? You union the initial query with the recursive query. So this query refers to the CTE name and uses the value from the previous query. So initially you have the initial query, then the recursive query gets executed, which uses the value of the initial query. Then the recursive query gets executed again, and this time it uses the new value that was created. The last value is always used to generate the next value. And the point at which the recursive query returns null is when this entire query ends. Okay, so you use with recursive to create this recursive query, and then you can use it in a select statement as you wish, like select star from CTE name, right? So this is the simplest form of recursion, and we look at a couple of examples to see how this works out when you're actually writing a query. So we want to first do a toy example, write a recursive SQL statement to list numbers from 1 to n, from 1 to 10. So let's try and do this. So first we are going to say with recursive, and let's just call this recursive common table expression nums. And I'm going to give the name, it's going to have just one column, and I'm going to give the, let's call this column num. Okay, so nums is the name of the entire query, the entire common table expression, and num is simply the name of the column. Okay, as Well, to avoid confusion, let's just call this n. So we are saying with recursive nums. So nums is the name of the common table expression, and it's going to have one column, and we are calling that column n. And as is used to begin the query, then inside brackets, we first write the initial query. So the initial query is going to be select 1, right? So I'm just going to put a comment here. This is the initial query. So there's no table being queried here. Here we are simply just selecting the number 1, right? So that is going to be the initial value, the value of the first row in the column n. Then we say union all. And now we have to refer back to the last value in the table, and we have to return a new value. Okay. So now we can say select n plus 1 from nums. So nums is the name. So we refer back to the common table expression nums. And what we are saying is give me the last value of in the column n. So initially the value of the n, initially the result only has one row, and the value under the column n, which is the only column, is 1. So when this recursive query runs from the first time, select n plus 1 from nums, it's just going to pick, n is going to get the value 1. So 1 plus 1 is going to be 2. Okay. And then it's going to run again. So it's going to pick the last row. So this value is going to be 2 plus 1, 3, and so on. But we want this to stop at some point. Otherwise it's going to keep running forever. So where n is less than 10. So only if n is less than 10, only if the last row has a value less than 10, then we should add a new row. If the last row has a value 10 or higher, then we should stop. So this is the recursive query. And this is the stop condition essentially, which is part of the recursive query itself, right? The stop condition is simply part of the recursive query. If this returns null, then the query is going to stop. Okay, so now that we have this common table expression, we can say select star from nums. Let's run that. And now you can see here there is a single column n, and it has the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now you can play around with this. What if the initial value is 4 and you set this to n plus 2, and then you set this to 23. So this is going to have 4, 6, 8, 10, and so on. Okay. So that's the simplest example of recursion in SQL. So all we do is we say with recursive, we give the common table expression a name. We give the column a name if required. We don't have to. Then inside the brackets, we first have a start query, select 1. Then we say union all. Here we can also say union distinct if we want to remove any duplicate rows, but union all is fine here. And then we say select n plus 1. So all we are doing here is we are creating another query which uses the CTE and the last value within the common table expression. And we select that. So basically there's generally a stopping condition like where, and then we select star from the common table expression. So that's one example of recursion. Now let's look at something that is actually useful and not just printing numbers from 1 to n. List the employee number, name, and designation of the chain of managers for the employee with number 1401. So if I go here and I say select star from employees, you can see here we have a bunch of employees, and if I just look at employee who has the number 1401, so 1401 is Pamela Castillo, and what we want to know is the chain of managers for Pamela Castillo. So first we want to list Pamela Castillo. Okay, Pamela Castillo is a sales rep and she reports to employee number 1102. So let's see who is 1102. 1102 is Gerard Bonder, and Gerard Bonder is a sales manager, and he himself reports to 1056. 1056 is Jeff Firelli, who reports to 1002. He is the VP of marketing and reports to 1002. 1002 is Diane Murphy, who is the president. Okay. So what we want to know is, given an employee number, in this case, employee number 1401, we want to print the information about their entire chain of managers. So how do we do that? Well, this is the good use case for a recursive SQL function, where first we want to get information about this particular employee, then we want to get information about their manager, and then we want to get information about their manager, and so on, right? So each time we want to use the last result to determine the next result. So let's start doing it. So say with, first maybe let's just try to get information about the employee number. So we'll keep it simple, and then we'll add in more information. So with recursive, and let's call this entire expression employee chain. So with recursive employee chain as, and then I'm just going to say select star from employee chain. Okay. So first we want to select e dot employee number from employees E. I'm just going to give this a name just so that in case I need to join or something, it's there. Where E dot employee number equals 1401. Okay. So far we've done nothing. This is just the initial clause. So let's just call this initial query. Okay. And I'm also just going to put this in brackets just so that it's super clear what the initial query is, and union all. And now we're going to write the recursive query. Okay. So remember, in the recursive query, we have to use the value from the initial query or from the common table expression, because it's always going to be using the last value. So now again, we want to select e dot employee number from employees E. So far it's the same. Where, what now? What do we want? We want to get information from the employee chain. So from the employee chain, we want to pick the last row, which is basically when we just want to select from employee chain. And we want to get the employee who the last member reports to. So I'm going to change this to from employee chain EC join employees E on. So we get the last row from employee chain. So, and then we check EC dot employee number, or sorry, for that employee, we check EC dot reports to. So we get the last employee in the chain, and to get that, we may also need to track reports to here. Okay. So in the initial query, we'll get the employee number and we'll get the reports to. So the employee chain will have two columns, employee number and reports to. Now we get the employee number and reports to for the employee number 1401. Then from employee chain, we get the reports to, and then we join with the employees column to get the value or get the information for the employee who this employee reports to, who the last employee in the employee chain reports to. So E dot employee number, right? So take the reports to number of the last row. So the last employee number was 1401. So they have a certain reports to. Take the reports to number, join with the employees table, get the data for the employee number whose employee number matches the reports to, and then for that employee, get the employee number and reports to, right? So we're joining with the same table. That's why this may seem a little difficult, and we don't need a where clause here, right? So all we are doing is, again, if I take away the initial query, if I just look at the initial query, so we have initially employee number 1401 reports to 1102. Then what we're going to do is we're going to say, get this reports to value. Using this reports to value, get the data for the employee who has the employee number 1102, and then return their reports to and their employee number. So that's what we're saying. We say select employee number and reports to from employee chain join employees, where employee chain dot reports to this value equals the employee number of the next employee. And let's run that and let's see what happens. So here's what it gives us. We say employee number 1401 reports to 1102. Then the recursive query executes and it looks at 1102. It gets information about the employee who has the employee number 1102. And what information does it get? It gets the employee number and reports to for that employee. So 1102 and 1056. Then the recursive query runs again. It gets the information for, based on the join, it gets the information for the employee who has the employee number 1056. So we get the employee number and reports to. Then the recursive query runs again. It checks for the employee who has the employee number 1002, and then it gets 1002 in this. And then the recursive query runs again and it checks for the employee who has the employee number null, and nobody has the employee number null. So the recursive query returns no output, and that's when the query stops. Okay. And that's how we have information about the employee number and we have the reports to information. The other information that we can add here is e.last name, e.first name, and e.job title. Let's add that in here. And let's add that in here as well. So now we have all of this information. Employee number 1401 reports to 1102. So that's Pamela Castillo. She's a sales rep. Then employee number 1102 reports to 1056. That's Gerard Bondur, who's the sales manager. And employee number Mary Patterson is the manager of Gerard Bondur. And she reports to Diane Murphy, who is the president. Okay. So this is how you can go up or down in the chain. And let's try that with one more employee. So let's maybe look at select star from employees. Let's try that with another sales rep, maybe Larry Bott 1501. So let's change that to 1501. And here again, sales rep, sales manager, VP sales, president. Let's try another. Let's try maybe 1102. Bondur Gerard is 1102 and he reports to Mary Patterson, who reports to Diane Murphy. Yep, so that's all there is to it. So this is how you find out the chain of managers for an employee. So let's take another look at that. We say with recursive employee chain as the initial query, which is to select employee number, last name, first name, job title, and reports to from employees, where the employee number is the given employee number. And then we union that with the recursive query, which selects e.employee number, last name, first name. But this time, employee number isn't 1401. Employee number is matching the reports to value from employee chain itself. And that keeps going till there are reports, and if there are no more reports, then it returns null, and that's when the recursive query ends. Okay. So try it out, try typing it out yourself, try to break it, look at maybe a couple more examples online and see if this makes sense. As I said, it's not something that will come up very often or even something that you will be tested on, but it's just good to know that this is there. So here's an exercise for you, bringing everything that we've done together. Create a stored procedure to list the employee number, name, and designation of the chain of managers for a given employee. So now instead of just using a single employee number, you want to take an input and then you want to use recursion inside the stored procedure to return the chain of employees. So that was everything that we were covering today. Here's a quick summary of the topics that we looked at. We started by looking at how to work with dates in SQL. We looked at data types and parts for dates and times. Then we looked at the creation of dates using functions like current date, current time, now, current timestamp, etc. We also looked at how to use the interval keyword to add durations to existing dates and times. Then we looked at some date arithmetic. So we looked at things like date add, date subtract. We looked at date diff, which is used to compute the difference in days between two dates, and time diff, which is used to compute the difference in hours. Then we looked at formatting of dates. So you can take a date time or a date or a time and you can present it in a human readable format in the way you want by using formatting strings. And you can also go the opposite direction. Let's say you get some information within a table is stored as a string, but actually represents a date, but it's in some fancy format. Then you can interpret it by providing the right format and create a date column out of it. Next, we looked at some advanced SQL clauses. We started by looking at the group by and the having clause. Then we looked at creating common table expressions using the with clause. Then we discussed the concepts of union, intersection, and minus. Then we looked at the case clause, which is used to include conditional logic within a SQL statement. So the case, when, then, else clause. Then we looked at some advanced SQL statements. We looked at stored procedures. It's a way to take a query that you've run and save it into the database and parameterize it with an input so that you can reuse that query without having to retype the entire thing. We also looked at stored functions. Stored functions are used to encapsulate logic within a small reusable function that you can use within a query. So that's the difference between procedures and functions. Procedures are called independently, whereas functions are used within queries. And finally, we also looked at recursion, which is when a query references itself in a SQL database. We looked at a couple of examples. One was simply generating the numbers from 1 to n, but the more interesting and useful example was generating the chain of managers of an employee in classic models. To learn more, probably the best place now for you is the MySQL reference manual. And as the name suggests, it is not something that you have to read through and remember. It's something that you will refer to from time to time, and you can search this manual, or you can even just search online on Google and you will end up on this manual one way or another. Let's say you want to learn about SQL statements. There are different kinds of SQL statements. Let's check maybe data manipulation statements. You have the delete statement, insert statement, select statement. For the select statement, you have the join clause. So you can learn more about the join clause here. It's the most comprehensive reference about SQL. It may not always make sense, but it is the ultimate source of truth about MySQL. Then you can use MySQL tutorials online. So mysqltutorial.org is a good one. This has better, understandable, readable, and human-friendly tutorials about MySQL, unlike the reference, which is very dense. So you can check out some of these tutorials, and we've covered most of this material already, but there's some that we have not. Full text search, for example, is something that is supported in MySQL. So you can look up this section to understand that. Or if you prefer watching videos, then you can check out MySQL tutorials on YouTube. This one channel has some pretty good videos. It's called Tech TFQ. It has videos on specific topics. And of course, you also have the lesson videos that you can refer to in the bootcamp. But it always helps to get another look from one or two other sources. It is often said that you need to read something from 3 different places to get a full understanding. So let one be this lesson, let one be a tutorial online, and let one be some video. And of course, you only need to do this if a concept does not make sense. Look at it from 2 or 3 different angles and it should start to make sense to you. But the best way to become good at SQL is to practice. It will take at least 40 to 50 hours of practice, at least solving 20 to 30 problems by yourself for you to feel confident in SQL. No matter how many times you watch videos or read tutorials, you will not feel comfortable. You will not feel confident. You should try writing all of these queries yourself. And the way I would do it is start playing the video, let the question come onto the screen, try to understand the question, then try to write the query yourself. If you're able to, that's great. If not, then watch the explanation, then put away the video and then try to write the query without looking at it. Just this simple exercise of testing yourself, even if it is something that you've just watched, will improve your understanding significantly. And you can repeat this with 3-4 questions at a time, so you can cycle through questions till the point that you feel like you've understood what you're writing. But beyond that, if you need more practice, then LeetCode is a good place online. So they have several questions related to databases that you can try out. The benefit here is that you'll get to work with many different databases and not just the classic models database. Then you have interview query, which contains a bunch of interview questions from various companies. So you can try out interview query as well. Then you can also check out Strata Scratch, which also contains a lot of SQL questions. Just try and solve 3 to 5 SQL questions every week. If you can try doing that, then within the next month or so, you will already be in a position that you can start applying for roles which require a good working knowledge of SQL. So that was advanced topics in SQL.